Just to start with a little bit of history on Sentinel. Established over 30 years ago, Sentinel is now the leading manufacturer of products and solutions for heating systems internationally. Initially renowned for water treatment chemicals targeted at traditional domestic heating systems, Sentinel now offers cleaners, inhibitors for domestic, commercial and renewable systems, including solar thermal, ground source heat pumps and air source heat pumps also. In addition, over the past decade or so, Sentinel has focused on physical products, again for commercial and residential systems, and these include innovative domestic heating system sludge filters, low-cost units to monitor corrosion in commercial heating systems to comply with recent BG29 changes, and of course scale protection as well. The SESI product to protect against scale formation in domestic systems, and CowGuard, which is a unique product for larger commercial systems protecting against scale formation, which Russ is now going to run through.
Okay, well, first of all, thank you for joining us. We've tried to cover off most of the technical issues that we might have. I'm in fact sat in my daughter's house at the moment because my Wi-Fi crashed this morning. If for any reason this breaks, falls over, Dave will pick it up and run from there. So don't disappear, please stay with us. So again, thanks a lot for joining us. So if we look at first why water treatment's critical, if you look at the top image on the right there, you can see that it's a pump head that's failed. Ultimately, that's likely to be caused by corrosion, whereas the image at the bottom there shows you scale that's come out of a 3-inch service pipe, would you believe? So originally a free area, 3 inches in diameter. We're now looking at something probably 22 mil, something like that. So the issues in terms of corrosion tend to be in closed loop heating systems where you've got water impurities, heat, different metals reacting with each other. Whereas in open loop system or once through systems, you've got fresh water coming in, the water gets heated, the scale deposits, and that's reciprocated time after time. In terms of the benefits of managing the scale, well, if you can keep the scale out of your asset and your system, then you're going to retain the efficiency of the system. So that's one of the very important things. In retaining the efficiency, you're going to minimize the amount of fuel that's consumed and obviously the associated CO2 emissions as well. What tends to happen if scale forms inside assets like water heaters or chlorifiers is they tend to overheat. So again, if you can keep that potential out of the unit, then the unit's not going to overheat and it's going to last longer. And finally, if you keep scale out of your systems, you minimize the likelihood of things like bacteria, Legionella to proliferate. So again, very important. If you're looking for guidelines, then you could turn to Part L. Part L suggests that you should use a trigger point of around 200 ppm to start managing scale. We work with lots of different clients like Premier Inn, Marks and Spencer, Sainsbury's, who have all got much lower trigger points. So we tend to suggest a trigger point of around 100 ppm. So any areas where you're over 100 ppm of hardness, use some form of scale management. Now, as well as looking at traditional softeners, Part L suggests that the only physical device that's suggested it within the guidelines are electrolytic devices, which our CowGuard is, and we'll go through that a little bit later. In terms of the HSE, they suggest it's a really good idea to keep scale out of systems because it will harbour bacteria and reduce or create a risk of Legionella. So if we look at map at the UK and look at those two trigger points that we discussed, everything over 200 ppm is shown in the dark red there. Everything that's over 100 ppm or between 100 and 200 is in the lighter red. So you're looking at 60% of the UK, and that tends to be where you've got porous rock, rain falls on the porous rock, drifts down through the rock, picks up the minerals as it goes. That's then pumped back up to the surface. It's cleansed so that we can consume it, but it still carries many of the minerals, such as calcium. Other areas that are grey there are probably where you've got granite rock and the water's then collected on the surface in reservoirs. That's kind of the main differences. Now scales, Mains water across the country will vary, as we've just been through that image. And what happens to the scale is, as you heat it, it starts to deposit, and where it's inverse soluble, those deposits will increase as temperature rises. And what you'll find is a very light off-white deposit that ends up being very, very crystalline and hard and very difficult to remove. Now, those deposits form almost like they form an insulating layer. So if you think about a traditional water heater, a commercial water heater, you'd have a burner at the bottom, a large vat of water above. You would heat that vat of water, consume it over time. Fresh water comes in, it gets heated, and through that heat cycle, scale drops out and sits on the bottom of the unit. Over time, those layers of scale will build up, and ultimately they're going to create a situation where you're going to need more and more heat to bridge that gap into your water. So if you look at that bar chart there, what that's showing you is you only need 1.5 mil of scale to form on the surface of a heat exchanger to cost you another 12% in fuel. Now, those of you that have been around a while, and I was the service manager for Hamworthy Heating, I've seen many water heaters where we've taken the mud door off, and the mud door is probably 150 to 200 mil from the base of the unit, and as you take the mud door off, the scale starts falling out. So those units that aren't looked after or inspected fairly regularly will have significant amounts of scale, so they'll be well in excess of 13 mil. So you can see the difference in terms of fuel consumption based on those layers building up. So if we just cross over a little bit into heating as well, if you were just to fill up a closed loop heating system and run the boilers, you've got a volume of scale within that system, calcium within that system, that will drop out in the heat source. If you have a problem with the system and leaks and you've got lots of makeup water, then as that makeup water comes in, it brings additional calcium. Again, as it's heated, you've got that reciprocating cycle again. If you get the heating systems treated properly with a scale inhibitor like our X100, then that process will be managed as long as you keep sufficient levels of the inhibitor in the system. But those two images there are kind of one that I spoke about earlier. If you look at the top image, that's where a mud door has been taken off the side of either a water heater or calorifier, and you can see that the scale's built up significantly. So, and again, the bottom one there, you can see a very similar kind of pattern. So the issues that you're likely to get are, I've already mentioned one where you're going to get the products potentially overheat. You're going to get reduced energy efficiency. From that first image that we saw right at the very start, you can see that pipe work becomes clogged. So pumps are going to have to work harder and again consume more energy. You will reach a point, if we go back to my water heater analogy, where you're heating up that metal surface and the heat can't get through that level of that layer or multiple layers of scale. It will stress the material and it will crack prematurely. Also, I've been into plant rooms where water heaters have been running away, and we've probably all had discussions while we've been making a brew in the kitchen alongside a kettle, those of us in hard water areas anyway, and you can hardly hear each other above the kettle. If you get that into a commercial setting with a water heater, the thing starts rocking and rolling. Those vibrations go through the building, and again, if you've got folks trying to sleep above that, they're going to have a problem. Also find on continuous flow water heaters, so more modern low water content products, that if scale starts forming on the inside, restricts the flow, that's going to increase the temperature within the product, and it will very quickly go out. So definitely something to avoid. If you look at the additional consequences of Limescale, if you run a large commercial building, what you certainly don't want is any downtime. If you think of a hotel, you need your hot water. You don't want surprise replacement costs, because if the product breaks down and fails, again, you're picking that up. We could bring planned maintenance in with that as well. You would potentially, if you don't manage the scale is going to build up within the product fairly regularly. I've spoken to FM guys looking after buildings and said, you know, you're in a hard water area, what do you do for scale? Well, we don't really get any problems here. We just descale everything every 3 months. Not the approach I would suggest. So you end up with those planned and unplanned consequences if you don't deal with the scale. And obviously in hotels you'll get the visible effects of crystalline formations around shower heads, taps, which again doesn't look very good and will potentially harbour bacteria. So how do we treat it? Well, we've broken it down into temporary solutions and permanent solutions. There are electromagnetic products out in the industry and these impulse field products where you've got wraparound wires. What they do is temporarily through ionization, they charge the particles, stop the particles sticking together and bonding to surfaces. But that's only temporary. So I think depending on which manufacturer you talk to, that might last for 12 hours. It could last for 48 hours. What you'll find with those, because they're temporary treatments, you may find that they have multiple units around a very large system. I think the largest system we saw with electromagnetics in London had 7 or 8 products to manage. It was a significant system, and we resolved that with a single CalGuard. There's a couple of other things that those particular products don't like, and that's turbulence. If you've got a convoluted route through a water heater, for example, or maybe through a pump set, that can undo that effect. And there's also something called LSI, which is Langelier Saturation Index. All of those products rely on positive LSI to function. So if we go into LSI, we're not going to go too much into the science, but if you look at the bottom there, there's those 5 critical elements. So if you were to take a water sample and measure the pH, alkalinity, calcium concentration and total dissolved solids, and then you knew what the temperature of the water would be as it passed through those temporary devices, you could work out where that sits on the Langelier Saturation Index, or LSI. Those particular types of products need to be positive LSI, so they need to be in situations that are scale producing to actually function. So if you look at those curves, you can see on this particular site, when on the initial test, it didn't get into positive LSI until you reached around 35 degrees. And then on average across the year, it was more like 45 degrees. So if we consider that mains water coming into a building would normally be maybe single digits, 8, 9, 10 degrees in the winter, and maybe in the summer, depending on how well it's lagged, it could be up at 20 if it's stored. You can see that if you put one of those temporary products on the cold main, it would have no effect at all because you're not into that positive LSI. If those curves and the chemistry had been slightly different and it had been down at maybe 15 degrees when it reached positive LSI, then we've had certain customers say to us, do you know what, in the summer when the temperature's a little bit higher, it works really well, but then as soon as we get into the winter months, it doesn't. So you have to understand what the chemistry is local to the site as to whether those types of products will be effective or not. In terms of permanent solutions, we always say that if you're dealing with a high-end client that wants a soft and lathery shower experience, then the only way they're going to get that is through a softener. With softener, obviously, you get an exchange between calcium and sodium. The things you just need to be careful on that is obviously the elderly and young kids in particular, and those with low sodium diets cannot drink the water. So you end up having to put additional supplies in. You've also got a situation where they have to regenerate each day, so they backwash, throw that water down the drain to take away the calcium that they've gathered. And obviously there's a certain amount of salt to buy, salt to store, and then somebody remembering to put the salt into the system. Along with that, you have got certain risks if you oversize it, that you can get, it is seen by some water authorities as a potential Legionella risk. But as I said, if you've got a high-end client that wants that soft and lathery experience, that's the only way they can get it. There are other water treatment products out there, reverse osmosis units. I've certainly worked on a few of those where we've delivered humidification into air handling systems to take the waterborne debris out of the system with very fine nanocron filters, which enables you to put moisture into the air without issues of fouling on coils or in worst cases, computer suites. CTUs or calcium treatment units and point of use filters, they tend to be used. I mean, we kind of use them with Sainsbury's, where CalGuard treats the whole system by being placed on the main. And then if you've got very high temperature units, such as steam ovens, then you would put one of these calcium treatment units on there, just to almost as a local softener type filter. And we have our CalGuard. Well, as you can see there from the list, it's you can put it on the potable side of the system. It's RAS approved. Going back to the first slide that we looked at, it's an electrolytic device, one of those recommended under Part L. It doesn't waste water, so every drop of water that goes through the unit you can consume. There's minimal maintenance really. You've got an optional filter which we recommend. That's a 55 micron filter, which effectively is a series of discs, captive discs on a rack. You could remove those 6 monthly, annually, depending on the state of your system. Separate the discs, give them a really good clean, and reassemble. So again, you don't have to stock spares. Maybe just an O-ring for the bowl, but you're not throwing away cartridges or anything like that. And the key thing that differentiates it from the other water treatment devices that we is it provides a permanent treatment. So as soon as the water's gone through the device, there is a permanent change in the calcium structure, which we'll mention in a while. It doesn't get affected by turbulence, and it doesn't get affected by LSI. So you don't have any of those considerations that we spoke about before, about water chemistry, turbulence, that kind of thing. There are other electrolytic devices out there, but ours is the only powered device, and I'll go through how that works in a wee while. The anode itself, there's enough zinc in there to last 10 to 12 years. When it's approaching the end of your life, the end of life, it pops up with an alarm. There's a code on the front of the screen, and it tells you that the anode needs to be replaced. In fact, recently I had one from the Mayor's office, and I think it was Bristol. I can't remember if it was Bristol or Gloucester, and they were just having to replace the anode, and it had been in for 17 years. But we say on most applications, suitably sized, you're probably looking at 10 to 12. Right, the process. What we basically do is introduce low levels of zinc into the system that attract the calcium particles and physically change their structure. So you go from a hard crystalline type of deposit to a very fine, I've had it explained as granular. So if you look at that bottom image there, that's actually the inside of an atmospheric water heater. The guys down at Southampton Uni, what they've said to me is what happens with their chlorifiers there, and they've got several CalGuards, is they drain down the chlorifiers or the water heaters, they take the mud door off, and effectively, in their words, they're left with like a sand in the bottom, which they then aquavac up and wipe over. And that's basically what they need to do to remove any deposits. And the reason why you get those light deposits forming in there is that's where you go into a low velocity area, and those small particles tend to drop out. So those deposits that do deposit, as I mentioned, is, if you look at it for the technical name, it's aragonite. As it arrives into the unit, it comes in as these big crystalline structures as calcite, but leaves the CalGuard as aragonite. Again, there's an image showing you. So there's a section through our anode. So you have the zinc in the center, and you have a copper pipe housing the zinc, and then brass fittings at each end. What happens is water comes in, it makes up the circuit between the zinc and the copper. You get electrolytic action, which drives current between the zinc anode and the copper cathode, which releases the zinc. So as I mentioned before, there's a few of our competitors out there that just literally supply that anode, and you kind of get what you get. You get around 5 to 6 parts per billion utilizing an anode in that way. If you look at the bottom image, there's the filter that I mentioned before. There's also a water meter, and the water meter is a pulsed output water meter. What happens is those pulsed outputs go into the controller as an input. The controller then works out how much current is required to drive across the anode to deliver the right amount of zinc. So effectively, what the controller does is vary the potential difference. So it changes the natural potential difference between the zinc and the copper. It varies it based on flow to deliver more or less zinc. And we're aiming for 25 to 30 parts per billion with CalGuard. Now, also with the water meter, because it's a pulsed output, you can use a pulse splitter. Now, the pulse splitter will, as the name suggests, as the output comes off the water meter, it goes into the splitter and splits in two directions. One goes into the controller to allow the controller to regulate the zinc released by the anode. The other one you can utilize into the BMS. We often seen it utilized to save a water meter inside the building where there's a BREEAM requirement. So there's a water meter on the boundary, and then the water loss between that water meter and our water meter is then utilized for the BREEAM water loss requirement. That's the kind of arrangement that we recommend. So there's a small bypass you can see between the two legs at the top. So if we come in through the main on the left, that could be the client's water meter there. But again, we could relocate our water meter into that location on the left-hand side. Flows up, down through our filter at the bottom, through our water meter, through the anode, and back into the system. The bypass is only really there for maintenance. And if the CalGuard's fitted upstream of a large storage tank, you would just make sure that the storage tank is full before you did any maintenance, and you wouldn't need the bypass. But anywhere where the client is going to lose water and that's going to cause them a significant problem, maybe if you haven't got a tank-based system, it's fed directly from the main, then we'd always recommend it's in there just to make sure that the supply is continued when you were servicing the product. You can see there that's pretty much pipe and fittings really on the mechanical side. And on the electrical side, you've got the controller, which has got a 13 amp fuse spur alongside it. That feeds in power. And then the other two cables that you can see going in there are from the anode and the water meter, and they come as part of the kit. So there's very little work for the guys to do. Those that install CalGuards tend to use them themselves afterwards because it is such an easy product to install. In terms of product selection, we're always trying to help you guys that are consultants out there in particular in terms of product selection. So if you look at the middle column, those are the peak flow rate capabilities of each size of anode. So for example, if you're looking for 3 litres a second requirement to make up your boosted system, so the mains water going into your tank rather than it's sitting on the boosted side, then you would be looking at a 54 mil unit, because that can manage up to 4.25 litres a second. And as you look at those anodes, the anode on the left-hand side is the 108. That's about 650 mil long, as are the 76 and 67. And when you go right down to the 22 mil unit, you're looking at around 400 millimeters long. So again, they don't take up an awful lot of space. And because we supply the equipment as loose components, you can arrange them to suit the space that you've got, which is particularly useful when you're doing refurbishments. So if we look at CalGuard in terms of a summary of key benefits, really, well, it's an electrolytic device, so it satisfies Part L. It's RAS approved, so it can go on your potable systems. It provides a permanent treatment, which doesn't degrade over time. It's not affected by turbulence, so you don't have to worry about the placement of pumps and that kind of thing. It's not sensitive to water chemistry in terms of the LSI element that we've been through before. I've just mentioned the peak flow rate requirements. That's what we'd normally look at rather than line size in terms of selecting it. And if you look at those points 2 to 6, what we're basically saying is you can position a single CalGuard on the mains cold water services as it enters the building, and it will treat everything downstream. And I think I've been through 8 before in terms of the pulse splitter. So it kind of gives you everything that you need. In terms of illustrating that, sorry about the quality of the drawing, but the kind of elements of it are the kind of the key points to show really. So what you'd have here, you can see a common storage tank, and then you can see 3 booster sets on the outlet. If you were using one of those temporary type devices, most of the manufacturers would tell you that they would need to put one of their devices on the outlet of each of those booster sets. Whereas if you look at the main coming into the tank, there's a single cow guard able to be positioned there based on it would be sized on the peak flow rate required to make up the tank. And you'd only ever need one because of that permanent treatment. In terms of warranty with the product, well, when it leaves the factory, it gets 12 months warranty. We include the cost of commissioning with the product, whether that's going to a merchant or directly to an installer. Once we've commissioned the product, the warranty is extended to 24 months. And then if the client instructs us to service the product within that first year, or at the end of the first year, we extend that warranty to 36 months. There's a report there on the right hand side, and that's kind of showing you the level of detail that we go into. You may not be able to see it, but what we can do is send you a copy of this presentation. Ultimately, what we try and do is we gather all the information about the cow guard, serial numbers, sizes, how it's been arranged. We look at the system. We look at where the cow guard's positioned, what the heat generators are, and it's all recorded just to help us further down the line if there are any issues, or we can help in any way with you, our client, or the end client themselves. Right, I think I just about did it in 30 minutes, which I think was what we were aiming for. If you guys would like to put your microphones back on now, if you've got any questions, we'd be delighted to help.
One thing from me, Russ, was maybe you should mention about the delayed action float valves and the application of those would help.
Okay, that's a good point, Sam. What we have within the range, we have 22 to 54 mil units, which we recognise can be put on just a main, and they're fully proportional. So we've developed the controls for those to be fully proportional. Once you rise to a 67, 76 and 108 unit, we always recommend the use of delayed action ball valves. And that's, as you're probably aware, that means the ball valve's either on or off, because the controls philosophy is slightly different for the larger units, because they tend to be for that kind of application. So in those situations on the 67, 76 and 108, you would be looking at a minimum of 10% of the nominal flow. So if we take, for example, peak flow rate capabilities of a 67 is around 7 litres a second. So you would need 0.7 litres a second to trigger the higher dose of CalGuard. But as I said, because most, I would say 99.9% of those products tend to be applied to tanks, our instructions and our recommendations on the quotations always state that we recommend the use of delayed action ball valves. And the reason for that is if the system is oversized or maybe the load's pretty low, you could have a trickle flow even through an equilibrium ball valve for a long length of time and not necessarily trigger the CalGuard. But as I said, that's applicable to the 67 through to 108, the 22 through to 54s are fully proportional and they'll regulate themselves up and down as they go.
Thanks, Russ.
No worries. Thanks, Sam. Thanks for bringing that one up.
Any other questions? No. Okay. Well, thank you all for your time today. I think.
Sorry, I've got one.
Go on.
I tried to put me out. Hi,
No,
Russ. Paul Chandler from Hampshire.
Hi, Paul.
Hiya, how you doing? Right.
Yeah, good. Thank you.
Sorry, I was just wondering. You were on your schematic there. We always sort of try and avoid any sort of bypass on an open, on a domestic water system for obvious reasons.
Yeah.
What's your view on that and dead legs and just on having is obviously you recommended it because of servicing, but we would normally not like to do anything like that at all. Well,
I understand that, and I know that's Hampshire's view on things. It's a recommendation from, so for example, if you're a client that's reliant on water on a regular basis, and I guess we can all say that, but something like a hotel or a restaurant, they just would not want their supply interrupted. So it's a risk management perspective. For them, there's probably a bigger risk in losing their punters, if you like, if they lose their water supply, And if they put the right regime in place under L8 or whatever the most recent version of that is, then you should be opening those bypasses on a weekly basis anyway, just to flush it through. And I think Thames don't like them either. So I completely understand the point of view, but I think in terms of most of the water companies at the moment will allow it, but it's a maximum number of pipe diameters, which escapes me. I think it could be 5, but I wouldn't. Don't quote me on that. I'm not sure.
Yeah,
so,
I can't remember either. Sorry. Yeah, and I just thought I'd put my camera. Yeah, and I appreciate that. As long as you say, as long as it's picked up in any Legionella management regime.
Yeah.
Guess it's I guess it, and as long as that regime is continues to happen and is logged, etc. I guess it's probably okay. But
but that's the only reason for it. It's really convenience for the client, and what risk not having that in might be to their business, I guess.
Yeah. Okay. No, fine. Thank you very much. Nice to see you.
Yeah, likewise. Thanks for joining.
Hi Ross and Paul. Sorry, it's Daniel Collins from WSP. Just a quick one on that. I mean, maybe what we could do for illustration would just be to move the isolation valve as far left or right as we can, depending on which side the incoming supply is in. I assume the left. So if we move the isolation valve as far over to the left to the T as we can, then you're reducing that dead leg as much as possible. Paul is obviously correct with the water authorities not allowing not liking the dead legs, but like you say, as long as they're flushed and as long as that valve is as close as possible to the incoming supply, then there's little to no risk really.
Yeah, it's as I said, it's not something we insist on. It's just a recommendation based on maintaining the supply and convenience for the client.
What we typically do within our specifications, especially when we specify something like this, or with something that where a manufacturer does recommend a bypass. Again, it's not something that we typically like. Is we put a caveat within the specifications that products must be ready to be kind of reordered, or one must be on site so they can be replaced within the time of the duration that the tank's been sized on. So there is, even if there is an interruption of supply, they've still got that storage volume within the tank to operate and change any parts.
Yeah, I think it's going to come into consideration a lot more now, because I think if you go back a few years, there was a lot of stored water. So your makeup rate into the tank could be a lot less. You could fill your tank up with water. And I know clients that have got 24, 36 hours worth of stored water, that they're, should they lose their supply, they'd be okay. But we're certainly seeing a lot more designs now where stored water is being reduced. So your makeup rate into the tank's being increased. And we just see it more as a risk to the business owner not to have it in. But again, it's fully up to them, and whether those maintenance procedures could be done out of hours and managed that way. I guess it's involving the client really, in terms of what's practical for them.
Yeah, thanks.
Thank you.
Good stuff. Any more questions? No. Okay. Russ, do you want to go to the final screen with the contact details? Yeah, so just we've listed there on the screen the contact details for the 4 regions, for your local or regional sector manager for the commercial. Obviously, if there's any details you need going forward, if you'd like to discuss water treatment in general in more detail, please do get in touch. And if you find today beneficial and you think other colleagues within your organisation would like something similar, then we'd happily arrange something at another time or date to suit yourselves.